Hello, General Biology, and welcome to screencast number 2 in section 4.1 of our chapter 4 series. And we've been talking about the climate, and we just got done talking about the greenhouse effect and how it warms up the earth. And now what we also have to take into consideration is our position on the earth, our latitude. One of the things that I think you've learned through the years is that the earth actually sits on an angle. It doesn't sit straight up and down. And what happens is that change that has an impact on how directly the energy from the sunlight hits the earth. So if our sun, and I'm not going to draw it, but I'm going to write sun. If our sun is right here, and that doesn't even look like sun, that looks like another word. Let's fix that up. So S-U-N. I am actually a much neater writer, but this pen doesn't show that. So if the sun is right here, this area is going to get the most direct angle of sunlight. And that's right at our equator, and we call that the tropical area, the tropic zone, which runs between 23.5 degrees south latitude and 23.5 degrees north latitude. And the temperatures that are going to be in this area are going to be very consistent. You're not going to see much change. At night it gets a little bit cooler, but we see temperatures on average of like 90 degrees during the day. And at nighttime, a chilly nighttime might be 70 degrees. Now, I went to Costa Rica, and Costa Rica is in the tropical zone. And when we went into the mountains, talk about microclimates, when we went up into the mountainous areas, it actually got down to 60 degrees. But the minute we got out of those mountains, which half hour away, and we were back up into the 90s, the high 80s and the 90s. So it stays consistent temperature. When we consider those above 23 degrees north latitude or 23 degrees south latitude, the angle of the sun is less direct on it. And because of that, we get a variation in temperature, and we get the 4 seasons that we have. So because of that, because we get the summer, the winter, the spring, and the fall. So the temperatures here, they could get to 90, 100 degrees on a hot day, but they can also get to 0 degrees on a cold day. So that's, and we're talking about Fahrenheit, not Celsius. So we've got this altering of temperatures throughout the year. If we go above that area, the poles, which are between 66.5 degrees south latitude and 90 degrees south latitude, and 66.5 degrees north latitude and 90 degrees north latitude, they don't get much sun. As a matter of fact, they spend 6 months of the year in darkness and 6 months of the year in light. So the heating there, it tends to be typically colder. So we get this uneven heating of the earth because of the angle of the sun, and that's going to impact our climate as well. The polar areas, as I said, they receive less intense solar energy, less heat from the sun, and this difference in heat distribution is going to create the 3 climate zones: the tropical, the temperate, and the polar zone. We talked about the tropical zone here in the middle being between 23.5 degrees north and 23.5 degrees south latitudes. That area is going to receive the sunlight directly all year long. Either side are the temperate zones, and they're going to receive less of that direct light. It's going to be on an angle. And then above that are the polar zones that we mentioned. The temperate and polar zones will receive very different amounts of solar energy at different times of the year because of the axis of the Earth, the tilt of the Earth. And that Earth also revolves around the sun, and solar radiation is going to strike it at different regions and different angles during the different times of the year. And that's why we have summers and winters and falls and spring. During the winter time in the temperate and polar zones, the sun is much lower in the sky, and because of that, the days are shorter and the solar energy is going to be less intense, and it's not going to heat up as much. So this unequal distribution of heat that happens across the globe is what's going to create our currents. It's going to create our wind currents, and it's going to create our ocean currents. So what we know is, and this holds true for both air and water, warm air is going to rise and cold air is going to sink. Warm water is going to rise and cold water is going to sink. That's because warm air and warm water are less dense, and cold air and cold water are more dense, so it sinks. So when we have this uneven heating and cooling, it's going to create the winds. And what you're seeing here in this are the currents that are created. The blue currents are the cold currents, and the red ones are the warm currents that you're seeing. And we can see how it's cold and then it warms and it gets cold again and it warms, and we get this cycling pattern that takes place. So air that is heated by warm areas of the Earth's surface, such as near the equator, is going to rise and expand, and it's going to spread northward, and also it's going to spread southward. And along the way it's going to be losing heat, and as it loses heat it sinks back down, and then it comes across the warmth of the land, and it will warm itself up and it'll rise again. In cooler regions like the poles, the air is going to be chilled, and it's going to sink down to the Earth's surface. And then when it comes to the Earth, it'll warm up and it'll rise again. This warm air, as it travels over the surface, will rise and again create those currents. These upward and downward movements are going to create our winds. So as you can imagine, the faster it heats or the faster it cools, the stronger the winds are going to be. And the winds are going to transport that heat from regions that have rising warm air to regions that have sinking cold air. And then the rotation of the Earth is going to cause the winds to blow, generally from west to east. Now they can change, and they have changed, but they tend to go from west to east over the temperate zones, and from east to west over the tropics and the poles. So here is patterns that we're looking at. I want to draw your attention to the aqua color. Those are the deep ocean currents. That's the ocean conveyor belt. The red line represents the warm surface currents, and then the darker blue, darker aqua will be the cold currents. And this is what drives the weather. We have a conveyor belt that comes up and passes through the coast. It warms up as it comes along the coast. It hits the Nordic seas and cools down, and it comes back down around, and that's going to transport the cold air and the moisture from that. So it's similar to the air currents, but it's in the oceans. So warm surface currents are going to add moisture and heat the air as it passes over them, and cool surface currents are going to cool the air as it passes over them, and the surface currents are going to affect the weather and the climate of nearby land masses. So we've been talking about Hurricane Harvey, and it was passing over warm water in the Gulf. So that warm water was evaporating and going up into the system, and it's going to create a lot of rains when it hits the landmass as it is. So deep ocean currents that we were talking about are caused by cold water near the poles sinking and flowing through the ocean. Salt water is more dense, and typically that is salt water that's going to sink really low. This water actually rises from the warmer regions in a process that's called upwelling, and it's taken up into the colder regions where it can cool down and come back down. This is the ocean conveyor where it circulates that water. Okay, that ends this section, section 4.1, and we will start section 4.2. Hope you're enjoying this. I am.